Warm greetings from TNV Academy. Today in this session, we are going to discuss about ISO 26262, which is Road Vehicles Functional Safety Standard. Let us take a look at the key learnings of this session. At the end of this session, we are going to learn about what this ISO 26262 standard covers. How is ISO 26262 different from other automotive standards? Components of ISO 26262 standard. What is ASIL? How to determine ASIL? And the last one is importance of ISO 26262 standard. So, let's start our discussion and talk about what this ISO 26262 standard covers. ISO 26262 is an international standard for functional safety in the automotive industry. The standard applies to electrical and electronic systems consisting of hardware and software components in vehicles. ISO 26262 defines requirements to be met by the safety relevant function of the system as well as by processes, methods and tools which are used within this development processes. The ISO 26262 standard ensures that sufficient levels of safety are being met and maintained throughout the vehicle life cycle. According to ISO 26262, functional safety is the absence of unreasonable risk due to hazards caused by malfunctioning behavior of electrical and electronic systems. These requirements minimize risks resulting from dangerous failures caused by systematic and random faults. This can be particularly complex and important for vehicles using modern technologies like advanced driver assistance systems that integrate on-board computers, sensors, and actuators to perform driver functions. Focusing on the automotive industry and road vehicles, the ISO 26262 series of standards addresses possible hazards caused by malfunctioning behavior of safety-related E/E systems, provides a framework for the automotive safety life cycle and supports defining activities for each stage of the life cycle, including development, production, operation, service, and decommissioning. Defines functional safety aspects of the entire development process, management, design, implementation, verification, validation, and confirmation measures. Provides an automotive-specific risk-based approach for determining automotive safety integrity levels ASILs. Uses ASILs to specify which requirements to apply to avoid unreasonable residual risk. Provides requirements for manufacturer-supplier relations. Now let us talk about what is the difference between ISO 26262 and other automotive standards. ISO 26262 focuses on functional safety, ensuring that automotive components do what they are supposed to do precisely when they are supposed to do it. It provides an automotive-specific approach for determining risk classes known as ASILs. AEC Q100, established by the Automotive Electronics Council, focuses on reliability, specifically stress testing for integrated circuit in automotive applications. The Society of Automotive Engineers (SAE) has long provided standards for rating automotive horsepower and non-defines best practices for cybersecurity in SAE J3061. The SAE is actively involved in defining vehicle autonomy levels and, more recently, developing automotive testing standards. MISRA, Motor Industry Reliability Association guidelines focus on security, defining the process for developing safe, secure, and portable software code in vehicle control systems. Now let us move forward and discuss about the components of ISO 26262. ISO 26262 uses a system of steps to manage functional safety and regulate product development on a system, hardware and software level. The ISO 26262 standard provides regulations and recommendations throughout the product development process, from conceptual development through decommissioning. In details how to assign an acceptable risk level to a system or component and document the overall. In details how to assign an acceptable risk level to a system or component and document the overall testing process. In general, ISO 26262 provides an automotive safety lifecycle management, development, production, operation, service, decommissioning and supports tailoring the necessary activities during these lifecycle phases. Provides an automotive specific risk-based approach for determining risk classes, automotive safety integrity levels, ASILs. Uses ASILs for specifying the items necessary safety requirements for achieving an acceptable residual risk. Provides requirements for validation and confirmation measures to ensure a sufficient and acceptable level of safety being achieved. We will now move ahead discuss about the term ASIL. Automotive Safety Integrity Level ASIL is a key component of ISO 26262 and it is used to measure the risk of a specific system component. The more complex the system, the greater the risk of systematic failures and random hardware failures. There are 4 automotive safety integrity levels values named AD. ASIL A is the minimum level of risk and ASIL D is the maximum. As you go from A to D, the compliance requirements get stricter. When determining automotive safety integrity levels, there's also a 5th option, QM, quality management. This is used to note that there is not a safety requirements for that component. Now we will take a look at how to determine ASIL. ASIL is determined by 3 factors: severity, exposure and controllability. Severity. Severity measures how serious the damages are of a system failure. Damages include both people and property. There are 4 classes of severity. S0, no injuries. S1, light to moderate injuries. S2, severe to life threatening survival probable injuries. S3, life threatening survival uncertain to fatal injuries. Exposure. Exposure is the likelihood of the conditions under which a particular failure would result in a safety hazard. The probability of each condition is ranked on a 5-point scale. E0, incredibly unlikely. E1, very low probability injury could happen only in rare operating conditions. E2, low probability. E3, medium probability. E4, high probability injury could happen under most operating conditions. Controllability. Controllability is a measure of the probability that harm can be avoided when a hazardous condition occurs. This condition might be due to actions by the driver or by external measures. The controllability of a hazardous situation is ranked on a 4-point scale. C0, controllable in general. C1, simply controllable. C2, normally controllable, most drivers could act to prevent injury. C3, difficult to control or uncontrollable. Once you are determined severity, probability and controllability, you can determine the automotive safety integrity level. And finally, let us now discuss the importance of ISO 26262 standard. ISO 26262 ensures that a high level of safety is built into car components from the start. It provides guidance for the entire automotive safety life cycle, from overall risk management to individual component development, production, operation, service and decommissioning. Using ISO 26262, OEMs can vet their supply chain and ensure that E/E safety hazards don't pop up later in the production process when issues are far costlier to fix. ISO 26262 accounts for the fact that in a growing majority of automotive electronic systems, vendors to try to save development time by designing hardware and software in tandem. The ISO 26262 committee outlined extensive guidelines for concurrent hardware and software development and testing, noting that they must be tested together to achieve the highest levels of safety. We have now come to the conclusion of this session. In case if you have any questions regarding the session and concepts which we discussed today, then please feel free to ask them in the comment section of the video. See you soon. Till then, best wishes from TNV Academy. Thank you.